Hi, algebra friends. All right, this week is all about the law of cosines. Hopefully you watched the video that was linked right before this, and you could see some applications of where the law of sines and the law of cosines can be used in the field of architecture. And those applications carry over to other STEM fields as well. So yes, you can use this after pre-calc. We saw last week that the law of sines works when we have two angles and a side given to us. Which left out some situations, and those two are side angle side and side 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 information. And so the law of cosines works when we have that. Here is the law of cosines. Notice it's written 3 times, but you'll notice some similarities. So each time it's written, we start with our a squared, b squared, or c squared. It's just written 3 times to show that you can use it for any of the 3 sides. You really only need to write this down once, and you just need to know the relationship between a, b, and c. So if you're starting it with a squared equals, notice you need to have these other 2 sides, and then that angle a right there. What I always remember is the side length that it starts with is across from the angle that it ends with, and then the 2 sides in the middle are the other 2. So hopefully that makes sense to you. And like I said, you should really only need to write it down once because it just moves its way around the triangle. Where does it come from? There is a proof here of the law of cosines, so this isn't math magic, and it comes from primarily the Pythagorean theorem. So if you would like to pause the video and kind of read through this proof, go ahead, but I'm going to keep going ahead and practice using this law of cosines. So we're just going to get started with trying a couple of them together. So let's write down that first example, letter A. And the directions say, use the given measurements to solve triangle ABC, round to the nearest tenth. Remember, when we're being asked to solve a triangle, it means to find all the missing measurements. So let's begin by drawing this out. I'm going to label ABC and then put my sides on there. So side length A is always opposite angle A. So that 8 would go right here. Side length B is always opposite from angle B. Our 5 goes here. And then C is 32.2. Notice my triangle isn't to scale. It probably will never be to scale, but I think having the visual helps us out a lot. We're given side angle side information. So to me, it would make sense for us to find this side length C first, because then what we can do is we can just use that formula, C squared equals A squared plus B squared minus 2AC cosine of C. And if we look through this, we know our side length A is 8. We know our side length B is 5. Oh, and I made a mistake when I wrote this down. This should be a B because these 2 letters in the front are the same. Again, we know A and B, and we know that angle measures C. So we can just fill in our numbers for that whole equation and then get out our answer. So let's try that right now. So A squared is equal to, C squared. That's what we're looking for. A squared is 8 squared plus 5 squared minus 2 times 8 times 5 cosine of 32.2. And we're just going to put this whole thing in our calculator. So I'm going to pick up my calculator and type that in. And I get out C squared equal to 21.3. But I don't want C squared, I want to know what C is. So I'm going to take the square root of each side and find that C is approximately, says round to the nearest tenth, 4.6. We are not given units, so I don't need to add units. All right, so I'm going to make a list over here on the left of all of the things I find. C is equal to 4.6. So I've got C. All right, what I have left are angles A and B. One rule with the law of cosines, okay, is you always want to solve for the largest angle first. So I'm going to come back up here and write that little note. Again, our rule with the law of cosines. Solve for largest angle first. And the reason we do this is because it eliminates that ambiguous case. And so we want to do that for a couple reasons. Number one, we didn't work with the ambiguous case in law of sines. Okay? Number two, the reason we didn't work with the ambiguous case is it has a lot of little nuances to it, and it turns into a lot of work. So we're always going to make sure we solve for our largest angle first using the law of cosines, and then we'll be fine, and we don't have to worry about anything going wrong for us. So you may be wondering, well, how do I know which side is the longest side? And we talked about that briefly when we did the law of cosines, but let's just review. The largest angle is always across from the longest side. So we just got 4.6 for C. Okay, 4.6, 5, and 8. Those are our three side lengths. 8 is the biggest, which means A is the largest angle. So we are going to solve for angle A before we go on to B. Largest angle first. So to solve for angle A, I need to use the two side lengths that are next to it, and then I'll also have to use the side length across from it. To solve for an angle, you need to know the three sides. So the formula I'm going to use again is A squared equals B squared plus C squared minus 2BC cosine of A. Remember, the first letter and the last letter always match up, and in the middle you use the other two. So that's how I can do this that easily without having to look back. I just see the patterns there, and I hope that you start seeing the patterns too. Okay, so let's fill in this formula with what we know. We know that A is 8. We know B is 5. We know C, we just figured that out, is 4.6. So we don't know this cosine of A. So we are going to have to isolate this cosine term, and once it's isolated, we'll have to use our inverse cosine to solve for A. So let's do some simplifying. What I think we should do, add these two together to get a single term, and multiply those together so we have our coefficient. 64 equals, let's go to our calculators. So I got 46.16. Oh. Move this down so we can finish our work. So we'll have to minus this 46.16 from each side. And then we'll divide both sides by negative 46. And I get a decimal answer right now. I get negative 0.3878, so on. Don't worry about that, okay? Because what this equals is the cosine of A. And we're going to use our inverse cosine to know what that angle measure is. So if you're getting something out that's negative or a small decimal, you're actually okay, because remember what we're getting out is a ratio. And what we'll find is our angle measurement. So this is where we're going to now take the inverse cosine of that negative 0.3878, and we'll get out our angle A. So use your inverse cosine, and I get, for angle A, 112.8 degrees. So we just found our angle A. All right, last thing we need is angle B. So that just brings us back to middle school. What do we know about a triangle? All three angles add up to 180. So let's just subtract from 180. So 180 minus 112.8 minus 32.2, and that gives us angle B equal to 35 degrees. Okay. All right, I think we should do one more together, and then we'll stop the video, and then you can do some extra practice in the practice B if you want some more before you move on to your homework. I'm going to clear this screen so we've got space to do our work here. All right, the next example gives us side, side, side information. Oops, have more erasing to do. So let's draw out our triangle. A, B, C. Let's label all of our sides. A is always across from angle A, that's 8. B is across from angle B, that's 9. C is across from angle C, and that one's 7. So first thing, solve for your largest angle. So the largest side length is 9. The largest angle is across from that. It'll be B. The first thing we want to solve for is angle B, which means our formula will start with the side length B. So we'll start with 9 squared equals 8 squared plus 7 squared minus 2 times 8 times 7 cosine of B. Same thing as before, I'm going to combine these and multiply these to simplify my equation. I have 81 equals 64 plus 49, 113, minus 112 cosine B. We'll have to subtract the 113 from both sides. Negative 32. And then divide both sides by negative 112. So I've got right now 0.2857 and so on equals the cosine of B. We'll use inverse cosine now to solve for our angle. So the inverse cosine of this ratio, 0.2857 and so on, gives me 73.4 degrees. So that's what my angle measurement is. All right, next we have to solve for angle A and angle C. I want you to try to do that on your own. Now that we've solved for the largest angle, you can choose to solve for angle A or C first, using the same method, using our law of cosines. Or at this point, since you have an angle and two side lengths, you could also use the law of sines to solve for those angles. That's fair game now that we have our largest angle on our triangle. So when we come back, we'll check our answers, and then we'll learn an area application that we can use based on the law of sines.